Hey guys, welcome back to the shop. We're going to jump back on to this V-block project right here. I want to go ahead and get these guys finished up. We've got to get the pair of V-blocks drilled and reamed so that we can get them bolt down to the fixture plate. So I'll talk through my, my initial setup and what we're going to be doing to get these guys finished. And before we do that, we'll go ahead and give you all a reminder in case you haven't seen it. We've got a couple of these fixture plates that we machined right here on the Flex. These V-blocks are going to be used here on the Flex CNC. I've got them bumped down. I've just pulled that one out there. You've got keys on the bottom that are machined to fit and center up on the bed rails here, like that. So it'll center those up. That one's the same way. We have two holes that have been drilled and reamed. We're going to have some 1/2-inch dowel pins that we're going to press into this. And then so we need to drill and ream the same hole pattern on the bottom of our V-blocks so that we can kind of bump them down onto those pins, and that's what's going to keep those guys straight and aligned to the fixture plate there. These are mounting bolts, so we'll have 4 flange nuts to hold them down to the bed rails. And then these holes are drilled and tapped 1/2-13 for these holes here, so we can use a stud or a bolt and bolt those down just like so. All right, so there's looking at the bottom of that guy there. So we need to come in here and drill and ream 2 holes to match our hole pattern on the fixture plate. So I'll show you what I'm thinking on our setup and how we're going to go ahead and tackle this job. So what I think we're going to do to get this done, I was going back and forth whether I wanted to try to do this in the CNC or the manual. I think we're going to go ahead and do manual today. I know a lot of guys like watching that. So I'm going to have these 2 angle plates. We're going to get those set up. We'll get them trammed across here. That's going to be our back, our fence that we're going to be able to put these against. But what we need to do is we need to make sure that our holes that are drilled and reamed in the bottom of this are actually located in the center of this V. All right, now these are milled very, very closely together. The other one's still sitting on the mill, but this width right here is pretty close, but I don't know if the V's are actually milled in the very center of this. So we could definitely set up and indicate off the edge and find, you know, go to the middle and drill and ream it on the bottom there, but it could be off just a little bit, probably a few thousandths one way or the other. So what I really like to do is have a piece sitting in this V like that. This is just a mock-up here. Just have a nice piece of material that's actually clamped into that V that we can center up on. So what we're going to do, this is same piece, this is a 2.5 inch. I've got this piece of chrome bar stock right here, and we'll cut a piece of that off and we'll drill it and tap it. And what we're going to do is be able to sit that down in here. It'll have a drilled and tapped hole. All right, so it'll be pulled against the V. So the first thing we'll do is go ahead and just drill us a hole in the center so that we can use a bolt and go ahead and bolt a piece of material to that V, and then we can come down next to it with our edge finder. We're going to make it long enough so that our quill won't hit this. So it'll be sticking out a little ways, you know, something like that. And we can come down here with an edge finder and find the very center of the round that's going to be sitting in that V. And then once we find that, then we can simply go to each side for our drilled and reamed hole there. All right. But we'll stand them up like this next to those angle plates there. And we can put a couple clamps there to pull them up against to that. You can use these holes here to pull it down that way. So that'll be simple enough. And then I was going to show you for our clamp, I went over to the welding shop. He had this piece of 2-inch tubing on the rack, just a piece of drop here, 3/16 wall thickness. So it'd be pretty strong. And I'm going to drill those. And then these are going to be used for our clamps, our clamp bars. And I've used these over the years. They work really well for that. You can see we've got some 1/2-inch holes tapped up there. So all we need is a hole pattern drilled in that. And then you can use a stud and these flange nuts to hold your workpiece down inside there. All right, so that's the game plan. We're going to go to the KBC mill and we'll get it set up and we'll do all of our machine work there today. Okay, we'll start with this piece that we're going to be used for centering our V. I've already found the center of this using a standard edge finder, and then we're 1 inch from the end right there. So we'll spot it, drill it, and then tap it 1/2-13. Just a spotting drill. And we got a 27/64 drill bit for our tap size, and we'll probably just go about an inch deep, I think. Slow that down. And then what I want to do is go ahead and get me a depth set. So I'm just moving the knee to line up on an even division on the quill scale up here. So I'm on the 1 inch line, and that'll be close enough. Just need a little bit of thread for our bolt to go in. We'll use a little bit of this CRC cutting oil on this. Go forward. Get down into that chrome quick as you can so it don't dull your cutting edge. That should be plenty deep right there. Now we'll go ahead and chamfer it also. Put it in low gear for that. And go in reverse. All right, that looks good. And we'll just use our hand tapping method to get the threads in there. All right, so we've got a spring-loaded center mounted in the quill, and we're just going to use a hand tap for this right here. We'll just go ahead and spray some more of this down in there. I know it's getting on the tap. I think that's it. There's the bottom there. Okay. That was our taper tap or your starter tap. I think I'll run back in there again with the plug tap and get a couple more threads down in the bottom there. All right, simple enough. That part is ready to go. Here's how our fixture and our setup is looking so far. Got our 2 angle plates. I haven't trammed it yet, but we'll show you guys that. I decided we're just going to go ahead and we're just going to sweep across the face of the actual V-block here and just get as center as we can. So got some hold downs, pulling it against the angle plate that way, and that's to kind of just keep it squared up against the side there. All right, and then we'll take this piece here that we drilled and tapped. After we drill our hole in the center, we will go ahead and bolt that on, and then we'll center up on that plug there to make sure that we have our 2 drilled and reamed holes center of the V. But to get started for this little fixturing pin here, I think it's safe enough that we'll just go ahead and find the center of it that way, drill our hole, and it'll be a clearance hole for a 1/2 inch stud to slip down in there, and we'll get that guy bolted on. So next up, let's go ahead and get this V-block indicated in line with our X-axis. All right, we're going to use our Starrett 196 back plunge indicator. Wow, it's looking pretty straight. I haven't even bumped it yet. That thing is, we don't have much movement in it. 5 thou. Looks like maybe 10 thousandths or so. That's a lot closer than I thought we were. All it did was I just eyeballed the edge of the angle plate down with this slot on both sides and just kind of snug it up there. So that was pretty close. Get our soft blow and we'll start bumping this guy around. I think our camera might work a little better right there. Let's go ahead and go back the other way. We just want to average it out, try to keep an equal distance, about the same on the dial. Looks like I went a little bit too far there. All right, so I'm just going to go ahead and recenter the 0 there. Surface is not perfect. This is just a piece of hot rolled plate, 2-inch stick that was cut out. So maybe about 5 thou. Let's just call that 0. Let's go to the other side and see if we can match that about right there. We may end up putting some, we've got our Fireball magnetic blocks that we could stick on there and give us a lot smoother surface to indicate on. We may try that too. So pretty close, and that's, I don't know, that's about 14 inches across right there. But what I want to do is go ahead and we're just going to snug the angle plates just a little bit. I don't have them very tight. And let's try something else. So I've got these magnetic blocks here from Fireball Tools that I'm always finding really good uses for, and I think in this case we'll just stick them here like that. And let's re-indicate this and use this surface here and try to average that one out. How about that? All right, let's call that 0 again. Go ahead and preload the dial. Okay, so maybe about 2 thousandths. I think that's going to be close enough. It's about on 0. Check the other side. I'm going to say that's within 1 thousandths end to end there, being trammed and in line with the axis of the machine. So we're just going to roll with that. So we're sweeping the top of it now just to make sure that this surface that we're going to be mounted on is parallel. So we've got the 196 set up there, and I've already swept it one time, and I'm happy with the way it is right now. So it has a little bit of a dip here in the middle. You can see it dropping about 5 thousandths in the center. And it'll go back up to about 0 right around here. All right, so I think that's good. I believe that the bottom and these top surfaces there where it's sitting on were actually milled parallel to each other, even though you got a little bit of a bow there in the center. You know, just keep in mind, this is just hot rolled mild steel it was bandsaw cut and then milled to shape. So it's not the best, but it's a good V-block and it's going to work well for how we're going to be using it. So there's no worry about it having that little bit of bow in the middle. The 2 bolts are going to hold it down on the ends just fine, and it's going to be good to go. All right, so I'm happy with that. We can go ahead and move on to finding the center of it, get our hole drilled so we can get our centering plug bolted onto it. All right, we are now in the center of the V-block, both this direction and the thickness there. Time to go on to our drilling. Let's get our hole in there. So we'll spot it, and then I've got a 17/32 drill we'll use to make a clearance hole for a 1/2 inch stud. And I think for some lubricant, we're gonna go in with our anchor lube today while we're drilling it, okay? We're going to have to drop the knee again. How about right there? Line up on our flats. There we go. Go in the back gear for this one. It's about 250 RPM right there. That's a good sharp drill, one of my Chicago Latrobe out of my big set. And usually whenever you're doing this kind of work manually, you run it a little bit slower and keep from burning up the drill. Clear some chips. All right, coming through the bottom. All right, well, they had their hole off center a little bit, but pretty close. All right, our anchor lube works good for that drilling like that. Help keeping the cutter cool and lubricated. Break that sharp corner off. Okay. So I think we'll just use one of our 1/2-inch studs and a flange nut here. Let's see if this is the right length that I grabbed. It looks like that might work. Looks like that's going to work just fine. And there we have it. A centering fixture pin right in the center of that V. So we'll put our edge finder back in there, and now we'll be able to find the center of this, and this will be the center of our V block, and then work off each side for our 2 drilled and reamed holes. So what we'll be able to do is see how far off center it is from where I actually indicated from. I've been in incremental, and then we'll switch over here to absolute. I've already got Y centered up on that, and now you can see where X is. We'll center up on this X using absolute, and we'll see what the difference is of where we were actually located at. All right, we've got it to where I'm in the middle of the pin. It's about 1200 RPM. All right, just kicked off the back side. We're gonna 0X. And let's go to the other side. All right, there's the edge. All right, so 2.998. We're gonna half of that, 1.5 inches to the middle. We'll go ahead and get it moved, and then let's compare our readings there. Let's not worry about that 1/2 thou. Look at that. Wow, we were only 4/10 off. So we really can indicate from this surface right there. So it looks like it was machined pretty accurately in the center of that, but not knowing, just taking guesswork off of that, I didn't want to take the chance, and I thought this was going to be our best solution, is to make sure that we centered up on the V. So that worked out pretty good, finding the center of it that way. So we can go ahead and move on and get our 2 holes drilled and tapped now. I'm sorry, drilled and reamed. So let's just double check our fixture here. These are the 2 holes that we're going to be matching up on, and it looks like I made those 8-inch center to center there. 8 inches, so easy. 4 inches to each side. That'll be simple enough. We'll get them spotted first. We've got our 31/64 drill loaded up. Here's one of the pins that we'll be using. It's a 1/2-inch dowel pin. So these are 1 3/4 inches long. Our fixture plate that these bolt to are 7/8 total thickness where these are going to press in. So that actually gives us about 7/8 that this would stick out. So I think the depth of our hole is, we'll make sure that we go at least 1 inch deep, but if it goes a little deeper, it doesn't matter. It's just going to be clearance at that point. And then we'll keep using our anchor lube for this drilling. Our slowest speed in high gear is 450 RPM. I think we'll go ahead and give that a shot. And it should work. We'll keep it lubricated. And I do need to get me a depth established, so let me do that first here. All right, so I'm on the 1.5-inch line on the quill. Just go ahead and get that full radius established and then adjust so I can look at the scale and make sure we go at least 1 inch deep. All right, I think that'll work there. So the 31/64 drill, that's 15 thou under the ream size that we're gonna be reaming it, which is about what you want for that particular size dowel. A good general rule of thumb to go by, because you may be doing a smaller diameter, is maybe about 10% of the diameter of the pin is maybe leave about 10% or so for the reamer. All right, so that's our inch deep. Let me just double check it. I think I'm gonna go another 1/8 of an inch. There we go. All right, let's go ahead and give it a chamfer. Put it in back gear for that. All right, that's looking good. Okay, we'll move down and go ahead and drill the other side. I do a manual chip break on this as we're drilling just to keep the chips short. And that should be the bottom where we need right there, about 1.125 deep. All right, I'll go find our reamer and that'll be the last step. This is my set of over and under reamers, and one of my viewers sent this to me several years ago. I've had these for a while and I've used them a few times. It's an extremely handy set of reamers to have. I can't remember who it was that gave this to me, but I hope whoever it is sees this and just know that I appreciate the gift. It's been very helpful around here. So it's made by LaValle and Ide Incorporated, Wendusky, Vermont. I've never heard of this brand before until I got this set here. So if you open it up, what you have is, this is considered an over and under set. So you have all your nominal sizes. You have this tray here that you can pull out. So it starts with the 1/8 of an inch, 3/16, quarter, 5/16, 3/8, 7/16, and half. And you have an over and under reamer for each size there. So for 1/2 inch, we have a 0.501 and we have a 0.499. And that is perfect for doing things like dowel pins. So we're going to use our 501 reamer, and I'm hoping that that gives it just enough clearance to where the pin, the dowel pin, will actually slip in and out of the hole where it's not too tight. We'll go ahead and ream one of them and and see how the fit is. All right, our reamer's put in a collet. We are ready to go. So I'm going to use our good old A-Bomb approved dark cutting oil for this. I'm just going to fill the hole up like that. I haven't used anchor loop for reaming. I'm sure it does fine, but I know my cutting oil does exceptionally well, so we're going to use that. All right, so we're going to run around 200 RPM and just hand feed it down to the bottom. Here we go. I want to try not to push too hard into the bottom whenever it touches, so I'm trying to go light-handed on the quill and just feel for it to naturally kind of stop. I believe that's it right there. All right, so let's try our pin. Ain't gonna work because it's got oil in there, but I think it's going in there. So let me get me a rag and let's blow that oil out of there. Oh yeah, that's the kind of fit that I was hoping for right there. You can see it's trying to suck it back in there. Perfect. So we should have about 1/1000th clearance over that pin. That'll allow the V-block itself to a little more easily get registered down without having to bump it in there. So I'm happy with that. Hole number 2. It feels like the chips start kind of packing into those flutes, and releasing the quill, bringing it up like that, helps them kind of drop down into the hole. That should be it. We got it. We're going to try to bump these guys in, or 2 pins anyway, into the holes here. It should be about a metal to metal fit. If not, maybe just a few tenths. I haven't measured it, but I'm just going off of our dimensions that we reamed it to. We used the 1/2 inch reamer, 0.5 reamer, and we have a 0.5 pin. So I am going to use just a touch of this anti-seize on here, like so. And we'll use the soft blow hammer. Now if it gets to feeling like it ain't going in there right, then we'll go over to my little arbor press, but let's give this a shot first. See if they'll bump in there. Bumping right in there, just like it should. Plan is coming together. All right, that should be good right there. See if we can get the second one started in there. All right, there we go. Well, that worked out. I didn't think that it was going to be that tight. So I'll go grab the V-block and let's see if it fits, okay? All right, for the top and the pins here, we'll use our SP350. That'll give it a nice coating of lubrication and rust inhibitor there. All right, here we go. I think I got it a little crooked. There we have it. I'm happy to see that. That was a pretty close fit, but I think it's so precision that I didn't have it exactly straight. And every time we bumped it, you know, we were shifted up or down on one side or the other. But we got it on there and it should be good. So now we can just use our either studs or a bolt. I might buy some bolts so I'm not using my studs on this all the time. We'll just get some dedicated bolts that we can keep it bolted down to all the time. Looking good. All right, so we're gonna go ahead and set up our second V-block here and do the exact same thing that I just showed you. Probably won't get a lot of video of that. Probably gonna get some stuff we can share on Instagram, get us something to make a reel. And we'll bring you guys back whenever we're ready to get this one mounted on there too. I just finished getting the second one drilled and reamed. I love the fit of these dowel pins here. At just enough clearance that they will just float and settle down into that hole right where they need to be. All right. Okay, so next up, let's go ahead and repeat the process. We'll get them bumped into the fixture there and go ahead and get it mounted. By the way, I did find some bolts there. So we've got these socket head bolts right here with some SAE washers that we'll use to hold it down to the fixture. All right, let's get one in there. Got to find my scale. Set it over here on the toolbox. All right, there we go. That's below 1 inch. Below 1 inch, there we go. All right, we'll go ahead and, I got my fan on. It's probably gonna blow it all over the place, but going in with our SP350 for some rust inhibitor and lubricant on the pins. All right, we'll get the V-block over here and get it bumped down on them pins. All right, coming in with the other V-block. There we have it. All right, that is looking good. I am happy to see this project at this stage here. Looking good. All right, so last up, I need to go ahead and get our tubing. I need to get it drilled so we can use it as our clamp bars. We'll go ahead and get that knocked out really quick, get those ends dressed, and that'll pretty much finish this job up. All right, we got our 2 clamp bars dressed on the ends there, deburred, got rid of all those sharp edges. Centered up, we're ready to just drill some holes in there. So we're going to be using a 17/32, so it'll give us a little bit of clearance over our 1/2-inch studs. And the center to center on those holes, it was a little bit odd, but I double checked it. It's 11 1/8 center to center. And so we have it offset from one end to where all we got to do is just drill a hole and flip it around, drill another hole, and repeat that on the other bar there. So let's go for it. Not going to worry about center drilling it, spotting it, or anything. We should be able to just go right on down through that workpiece. If it walks to one side or the other, it's not really going to make a big deal to me. Just let the tip of the drill kind of get a chance to center up on it before you bear down on it. Same thing in the bottom, just kind of go light on the feed to let it kind of center itself up. So what we'll do is just flip it around, repeat it. And I'll come back after we drill it to put a nice chamfer on there. All right, our holes are drilled. We'll go ahead and chamfer all of them now. Go ahead and slow this guy down. These chamfer tools, you just don't need to run them very fast. You just really want to break that edge like that. Guess I should have flipped it over. I think what we'll do is I'll take these guys home to the evaporust bath that I have and let them soak in there and get rid of all the surface rust. That one looks like it. Oh, it's fine. Drilling through that thin material, them drills like to try to walk around. There we go. I'll reach in there with a deburr tool and go ahead and deburr the inside of it, and we'll test fit them. Okay, we run a tap in these holes, clean out the dust that was in them. Got them blown out and ready to go. They're not consistent on depth. This one's a little bit deeper than those, but not a big deal. Looks like these are a little bit deeper than those. So here's our clamp bars. Just like that. You can take some of these flange nuts and screw them down. And so depending on what size workpiece you have in here is what's going to determine the length of the stud you use. But when I was running that horizontal bore mill a lot, we would have large tubes in here, you know, hydraulic tubes and even gearbox shafts. And then sometimes, you know, they'd be up here like that. So just depends on what size your workpiece is. You can even use the coupling nuts and, you know, make it a lot higher if you need to. I don't have any lightweight rounds. All I got is that big gearbox shaft to put in there to show you. But we're going to be getting some work pieces in here so we can put these guys to work. There it is. What I would like to do is go ahead and get these guys bolted down with our 5/8 hardware to the bed rails. And then I'll get an indicator set up there on the flex, on the spindle, and we'll sweep across these surfaces here. I'm curious to see how close they are. I'm hoping they were going to be within a couple of thousandths of each other, but that's going to be the next phase. But other than sweeping it with an indicator, these guys are finished up, and I'm real happy with the way they look there. They should work really well for some nice large work pieces that we're going to work on here in the flex. All right, you're set up inside the flex. We've got a dial indicator set up there on one side, and we just want to see how straight and parallel these two surfaces are to each other. All right, so one side zeroed out, and if you move this across here, let me slow that down a little bit. From one side to the other, you have a little bit like it wasn't milled perfectly square, but that's okay. This doesn't have to be perfect. Let's go on down to the other side. Slow it down a little bit so it doesn't jump. So about 2/1000ths is what we're getting right there. And if we come all the way across the other side, it jumps up to about 3.5 thousandths or so, somewhere in that range. So it's looking like we're right around maybe 2 to 3 thousandths difference on being perfectly aligned on those edges right there. I was sure hoping for 0-0, but that's asking for a lot with these mild steel V blocks that were handmade, basically. I'm happy with the results right there, and as I had mentioned before, either in this video or a previous video, whenever you put a precision part inside those V blocks, let's just say a shaft, precision shaft, you're going to sit in there, you can indicate the workpiece at that point and shim, just use some brass shim stock, and you can shim underneath the workpiece as you need to try to get it to shift one way or the other. Same thing with height, up and down, do the same thing. So that's going to put us within a couple of thousandths of being true to each other, and I'm real happy with those results. All right, guys, that's going to wrap this project up. I'm happy with the results. I think we've got some really good V-block fixtures here that we can now use on our Flex CNC. So I've been trying to work myself up to this point. I've been practicing and getting to know the machine better and how to operate it properly. And I know I got folks that want to see some big shafts and some things like that cut in this machine. I've just been really worried about getting an expensive piece of shafting or something like that in here and then totally screwing it up because I'm not familiar with the machine. So I'm continuing to learn how to operate this and how to do CNC work, how to use Fusion to make programs so we can come over here and make parts. Just like that, we're still working on that. We're going to have a follow-up on that pretty soon. But these guys are ready, and I'm that much closer to getting some large work pieces in the Flex there. I do think I would like to clean these guys up a little more and maybe put a paint job on them and make them look a little bit nicer than just straight up raw steel. So we may work on that. I'm definitely going to de-rust these guys, and maybe down the road we'll see about getting a nice paint job on these. All right, but until then, I hope you guys enjoyed the project, enjoyed the video. Thank you guys for all your support. I really appreciate it, and I hope I see you again on the next project. See you guys later.